Welcome. In this video, I'm going to show you how to compute all four second partial derivatives for this function g given here. Before I go on, I'm just going to hide this a here since for now this is still a of my guided notes template, but it might not always be. All right, so let's begin first by computing the partial of g with respect to x. From this one, we're going to compute both the partial of g with respect to x squared, so the second derivative with respect to x, and we're also going to compute the partial of g with respect to y with respect to x. But first, let's begin with this. And give me a moment to move this out of the way here, since this is just kind of an aside. So the partial of g with respect to x is equal to 6xy. So I'm treating y as a constant and using the power rule for the derivative of 3x squared minus 2y plus 7y cubed. Now the partial of g with respect to x squared, that's the partial with respect to x of 6xy minus 2y plus 7y cubed. So this is 6y. This will just vanish since we're treating y as a constant, as will this one. This one will also vanish. Now let's work on the partial of g with respect to y with respect to x. That's equal to the partial with respect to y of 6xy minus 2y plus 7y cubed. Pardon that screen move. So this is 6x minus 2 plus 21y squared. So the derivative of y here is 1. Similarly, this derivative is 1. That's how we end up with the negative 2. Now remember, we treated x as constant, and that's why 6x is here with the derivative of y being 1, this derivative being 1 as well, and then using the power rule to get 21y squared. So this is the partial of g with respect to y with respect to x. Okay, so next what we're going to do is figure out the partial of g with respect to y. And from this, I'm going to move this, by the way, those of you taking notes on paper should just write it here in your side area. On a tablet, you can move it as well. So from here, we're going to get the partial of g with respect to x with respect to y, so the other mixed derivative, and the partial of g with respect to y squared. All right, so let's go ahead and get started. The partial of g with respect to y is equal to 3x squared minus 2x plus 21xy squared. Again, the derivative of y here is just 1. Similarly, the derivative of y is 1, and then I use the power rule here to get 21xy squared, since we're treating x as a constant. Now let's compute the other mixed derivative, the partial of g with respect to x with respect to y. That's the partial with respect to x of 3x squared minus 2x plus 21xy squared. So this is 6x minus 2 plus 21y squared, and that is from using the power rule here and recognizing the derivative of x with respect to x is 1 for both of these terms. Okay, now let's compute the partial of g with respect to y squared. So that's the partial with respect to y of 3x squared minus 2x plus 21, excuse me, I lost that x there, xy squared. So the first two terms will vanish since they don't have y's and we're treating them as constants, and we end up with just 42xy. Okay, I'm going to make a little space and then recap everything here on the side. So the partial of g with respect to x squared, that's equal to 6y. The partial of g with respect to y squared, so the second derivative that is not mixed, is equal to 42xy. the partial of g with respect to y with respect to x, that's 6x minus 2 plus 21y squared, and the partial of g with respect to x with respect to y is equal to 6x minus 2 plus 21y squared. And as you'll notice, the mixed partial derivatives are equal. So please look out for this lovely feature to ensure that your work is correct. There is a theorem proving this, but it's not something we will go over at the moment. Okay, please remember to keep calm and math on.